host na hindi makakasama ngayon. Okay, so right now, nandito na tayo sa hypothesis testing. So we're scheduled for hypothesis testing today. Tapos yung estimation, I'm assuming you have read this already, no? Because we will be needing or parang it would be better if you have read this topic kasi mas madali nyo maintindihan itong si I'm sorry. Madaling maintindihan itong si hypothesis testing if you have read estimation, no? Okay? So I've already opened up and let me view as a student. Binuksan ko na rin yung additional na modules, no? Yung modules 8 and 9 for those who want to do advanced reading. Ang requirement nito is that you should have done hypothesis testing, no? Because hypothesis testing is the parang kumbaga basics on how we deal with statistical data, no? And how we arrive at conclusions. And ANOVA is just one way to do, or ANOVA is a type of hypothesis testing, no? Okay, so if you have already done your hypothesis testing, pwede na kayo mag-proceed sa two-way and higher ANOVA. And again, si one-way ANOVA will be supplementary, pero you'll have to read about one-way ANOVA in order to appreciate or parang para mas madali yung magiging understanding nyo on two-way and higher ANOVA. Okay, pero wala ng modular assessments dito. Okay, so many have been asking class, no, sa emails and chats kung meron bang hard deadlines yung mga modules natin. So again, I'd like to reiterate na yung course natin is the course MMME14, yung iteration natin for today for this sem is meant to be done at your own pace. So meaning wala talagang deadline within the SEM. So you'll have to do, or kayo magde-decide kung when you want to do the modules and how you want to pace yourself. No? So the only hard deadline is yung anong tawag dito, yung end of the SEM. So you'll have to finish all of the modules by the end of the SEM if you want to receive a passing grade. Now, I would advise against I would advise against cramming. So as early as now, dapat mas maganda kung masundan nyo yung schedule na nakalagay dito, no? So if you look at you can look at the schedules, no? Meron naman siya dito. So it's ang rule of thumb natin is maganda kung natapos nyo yung modular assessment 1 week after scheduled yung module. So for example, yung hypothesis testing is due on or is scheduled today or 11 and 16 siya. So maganda kung matapos nyo siya the next week para on pace kayo. So kung 16 siya, maganda kung matapos nyo siya on the 23rd. Okay? So yun yung rule of thumb natin. Para if you want to parang pace yourselves according to this course outline. But again, it's because it's do it at your own pace, then you can decide if you want to do it faster. So pwedeng tapusin nyo na maaga, tapos you can do advanced readings, or pwede rin you can do it slower, no? Tapos hintayin nyo muna yung lectures, tapos after the lectures, tsaka kayo gagawa ng hypothesis testing. It all depends up to you guys. Pero again, I would just like to remind na dapat be very wary of the schedules, no? Because baka maabutan kayo ng end of the SEM tapos magka-cram kayo sa dulo na. And some of the modules, again, I'd like to reiterate, some of the modules require that you finished the other modules, no? So hindi ka pwede mag-skip sa mga modules na yun. Okay? So nakasulat naman siya dito. If you look at the bottom right corner of each of the modules, merong nakalagay na restrictions. So for example, itong estimation and estimation, ang restriction niya is probability. So you'll have to do probability before you can access. Ito, hindi ko nga ma-access to because sa student account ko, hindi ko ginawa yung probability quiz. So that's why I can't access. Okay? So I've also added, hindi ko alam kung napansin nyo, and I think some of you have already noticed, no? Merong feedback na portion dito sa each of the um, modules that are assigned to us itong sa mga tiles na to. I would appreciate it if you take some time to answer the modules, no? So this would help us improve the course for future iterations. Okay? And also kung sasagatan niyo siya na maaga, we could also address yung mga glaring concerns, and we could apply them immediately sa mga future modules, like for example itong or future modules within this sem, no? So kunwari yung module 10, 11, 12, 13, 14, pwede namin i-apply na yung mga feedback na ilalagay nyo dito. So hopefully sana you can take the time to answer them, right? So with that out of the way, let's proceed with module 7. No? And module 7 is all about hypothesis testing. And I'm assuming, again, you have read the lesson on confidence intervals and or estimation. No? So basically, ang sinasabi lang ng estimation is, and just to recap, no, if a process is normally distributed, which we assume all processes are, no, unless there are certain conditions that make it skewed to the left or skewed to the right, we are assuming that all processes are normally distributed. No? So we can draw it something like this. So parang it's a frequency distribution, no? Yung normal process. And we are saying sa confidence interval that given some form of information and dun sa confidence interval natin is, or sa estimation is, we had 7 cases, I think. 7 nga ba? Or 8? Analogo siya dito. Let's see. 9 cases. Okay. So, ito, these are just analogous cases to the cases that were presented in estimation. No? So there are 9 cases. And doon sa 9 cases na yon, it deals with different quantities. No? So you can estimate the kunwari, mean of a population. You can estimate the variance of a population or the standard deviation, and so on and so forth. And there are certain cases where you have unique conditions like paired observations, or you have yung mga before and after conditions, yung mga ganong klaseng conditions. No? Pero essentially, what it's trying to say is you are trying to estimate a statistic. So just to recap, no, kung anong ibig sabihin ng mga words na to. A statistic is a an estimate of a population parameter. Okay? So yung analogy is kung meron kang if this is your sample tapos population, if you have a parameter in your population and you want to estimate that parameter, we call that as a statistic. Okay, so a good example is, for example, if you have a parameter that is the mean, the population mean, then the statistic will be your x bar, no, the sample mean. So if you have standard deviation, that is the parameter, the statistic is the SD, or standard deviation, the sample standard deviation. Okay, so parang ganito siya. So what we are trying to do here is, because in estimation, if in like any other parang statistical process, parang imposible, or it's very difficult if not impossible to get a population parameter. So try to imagine kunwari trying to survey the entire Philippine population. So parang imposible siya, no? You'll have to go house to house, and posible pa pag pumunta ka sa isang house, wala yung taong yon, so you have to come back. So just try to imagine lahat ng mga tao i-survey mo. So it would be very difficult, in fact impossible siya, no? So that's why it's necessary na instead of dealing with the large enough numbers or a very big number, we just take a portion of that number to, and that portion will hopefully accurately represent the entire population. And the science behind sampling is or sampling itself is a whole different science in itself, no? So hindi na natin siya itatakol, pero the assumption is if we get a sample, we are saying na that sample, kung whatever statistic na makukuha natin doon, we are at some level of confidence um, sure na parang it can accurately represent the population parameter. Okay? So now we have what we call as a confidence interval, no? Or CI. So confidence interval is saying that in some percentage, meron tayong or there are many ways of interpreting the confidence interval, no? But one of the popular ones, and although this is a parang loose interpretation of confidence interval, is saying that, for example, if we have the common confidence level is 95%, no? But we can also have 99 and 90%. So it depends on the test. Usually for engineering and other sciences, na 95% yung madalas na ginagamit, no? Or sometimes they can use 99 and 90%. Okay? So pagka sinabi nating 95%, we are saying that that the statistic na kinuha natin, so usually pagka may confidence interval tayo, we have a statistic plus minus a certain na error value, no? Okay? So that's our plus minus. Okay? So let's just say, let's put some numbers here, no? So kunwari 25 plus minus 2 yung nakuha natin na, and let's say na ano to, no? Percentage na lang to. This is the percentage of those who will vote for a certain candidate. Plus minus 2 siya. So we are saying na the actual parameter will be in between 23 to 27%. So the actual population parameter will be 23 to 27%. And again, hindi natin kaya makuha to exactly to population parameter, not unless we actually do the experiment itself. No? So we are trying to estimate it, and we're saying na for a certain confidence interval, and let's just say 95%, at 95% confidence interval, we are sure na 23 to 27%. So another way of saying that is there is a 95% probability that the population parameter, the true population parameter, is in between these two values, 23, 27%. So that is a loose definition of the confidence intervals. No? Pero some of the purists will argue with that definition, no? Kasi um, it was never meant to be interpreted that way daw. Pero for our case, parang acceptable na yung ganong interpretation, no? Because parang for us in engineers and some of the I don't know other fields also agree with this. Parang it is representative naman yung interpretation na ganon. Ang purist na definition is that instead of probabilities, kasi meron pa yung different kinds of probabilities, no? Hindi ko na siya i-go into it, pero parang something like I myself don't fully understand it, no, pero parang there is different probabilities depending on how you define probability, no. So kaya nagkakaroon ng issue sa definition na yun. Pero yung purist ang sinasabi nila is instead of saying na there's a 95% probability that it lies between 23 and 27, parang sinasabi nila is if you do the experiment 100 times or n number of times, let's just say 100. If you do the experiment 100 times, then 95 times out of the 100, yung population parameter mo is in between 23 to 27. Ganun. The rest of the 5 na times na ginawa mo yung experiment, magpo-fall out siya doon sa itong confidence interval na yun. Okay? So, if I were to ask you kung kayo yung mag-interpret, parang they mean the same thing, no? Would you agree? Or sa inyo ba parang sobrang iba ba yung definition na yan? Would that like to get your opinion on this? Meron ba kayong ano? Parang sinasabi ni Shane, parehas lang. Yung iba, ano yung You can do thumbs up if you agree kung same lang ba, or thumbs down kung magkaiba sila. So, some of you, Kenneth says na mas maganda yung unang definition. Usually in introductory classes, no, parang yung unang definition talaga binibigay kasi parang mas ano siya, kumbaga mas friendly siya na interpretation, no, at mas easily absorbable. Okay? So, for this class, no, we will accept the first definition, no, na parang it's accurate enough for us, it's applicable for us, tapos parang madali lang din naman maintindihan. So, in future na lessons, no, when we talk about confidence interval, then we'll just talk about it in that sense, no, that again, if I would reiterate, sinasabi natin na if we have a confidence interval, and we can represent it by this graph right here, parang sinasabi natin na whatever value na nakuha natin, plus minus, we are not, there is a 95% probability that the true population will lie in between this interval right here. Okay? So yan yung estimation. Okay? So although estimation is important, no, lalo na pagka mga social sciences. So think about the election survey kunwari. It's important, no, because election surveys, parang although parang hindi na ako naniniwala sa mga surveys ngayon, pero in general, ang election surveys kasi is a way to, I don't know, to try to estimate kung ano yung, or estimate or predict the outcome of the final elections, no, parang ganun. So when you see if you look at mga election surveys, no, yung mga reputable election surveys, usually meron silang nilalagay na plus minus, so it's accurate plus minus. I think yung Pulse Asia is 2% o plus minus 2% sila. So parang sinasabi lang nila doon na that is their confidence interval. So whatever value na nakuha nila, that is a confidence interval, no? So by our first definition, they are 95% confident that, or they are they are saying na there is a 95% probability that the true outcome or result of the election will be within plus minus 2% of whatever they got from their survey. Parang ganun. Okay? So it in that sense, it's important, no, pero if you think about engineering applications, parang hindi masyadong useful sa atin yung estimation, no, kasi so sometimes it's useful, pero most of the time, instead of saying na and let's take this example for let's take this for example, no, itong si parang mga rebars na to. So for example, instead of saying na etong rebars na to, we want to get the true population na true population parameter, for let's say for example meron siyang yield strength, no, so that's one property of this material. Sabi natin, let's just say ang yield strength niya is 500 MPa. So we got an average of 500 MPa plus minus let's say 20, no, MPa. So hindi masyadong useful tong value na to, no, na we're saying na we are 95% sure na or there is a 95% probability na yung true parameter of the entire rebars na napoproduce ng process natin will be within 500 plus minus 20%. Sometimes it's useful, pero most of the time parang that value doesn't really mean anything, no. What is more useful to us is if we get a sample, kunwari ito, kunin natin tong sample na to. Tapos we measured the value, tapos let's just say ang nakuha natin is 490, parang ganyan. Tapos etong 490 ba, is this 490 here parang within the true population, or parang did something go wrong sa process such that out of specification na to? Yan yung parang mas engineering na application. Instead of trying to estimate, gusto natin na we are trying to assert a particular hypothesis or we are trying to do a particular assertion na is this out of specification, is this within specification. Tapos using statistics and using the same concept as your confidence interval, gusto natin malaman kung lumabas pa siya doon sa interval na yun or pasok pa siya sa interval. So technically, same pa rin yung treatment, and if you look back at the formulas, no, it's actually just a rearrangement of the formula. So if you look at the summary dito, and I can probably show you the summary here. Tapos buksan ko yung isa. Hanapin ko lang class. Estimation. Let's just look at case 1. Para ito. And sige, palitan ko yung Let's do a side by side. So if you look at it, same lang actually yung value niya. Look at this value here. Itong nasa loob. Saan yung draw? Tingnan itong value na to. This is, yung plus minus daw niya is z alpha over 2 multiplied by the standard deviation over square root of n. So that's case 1, no? Tapos dito naman, you'll notice na this is x bar minus mu naught over sigma divided by square root of n. So this is actually just a rearrangement of this one. No? So if you do x bar, and let's take the plus na plus value, no? Itong plus z alpha over 2 sigma over square root of n. Parang ganyan. So, since parang to the left and to the right lang naman to, itong plus minus na to, then we can just take the positives, positive value, no? Kasi it will just mean we are dealing with the either left tail or right tail. Parang sinasabi natin ganito. So, if you were to represent it with the normal distribution, itong border na to dito, this is our right tail. Kasi itong left border is our left tail. So, if this is our mean, plus yung plus z alpha over 2 sigma square root of n, ito yung papunta dito na direction, and ito yung minus na direction naman. So let's just take the plus direction. No? So if we take the plus direction, then we can see na if we try to rearrange this, we can put it and let's equate this to 0. No? So we can say na si z, if we try to get z is equal to x bar, this is equal to not 0, is equal to mu naught, no? Kasi ang sinasabi natin, this is an estimate. We are estimating the population, the sample statistic. So this is the statistic. We are estimating it. We are estimating the population parameter, which is mu naught, with this sample statistic x bar. Tama? So itong value na to is equal to mu naught. Tama? So kung equal siya sa mu naught, if we do the rearrangement, and ang kinuha niya pala is mu, yung minus yung ginamit niya dito. So let's just use the minus. No? But later on, it wouldn't really matter. No? So it's x bar minus z alpha over 2 sigma over square root of n. Kasi most of the tests are two-tailed tests, no? Wherein symmetrical naman tong distribution natin. So it wouldn't really matter kung if you take the left interval or the right interval. So let's take the left interval, then try to readjust. So if lilipat natin yung mu bar dito, it becomes x bar minus mu naught pala, is equal to, lipat natin sa kabilang side yung z. So that's z alpha over 2 multiplied by sigma over square root of n. Ganyan. Okay? Tapos, if you want to get the z, then we just divide this value right here. Ito, lipat natin sa kabila. So that becomes sigma over square root of n. And if you'll notice, ito, this is the same value dito. Tama? So, again, hypothesis testing has the same formulas or equations as the estimation. It's just that iba yung kumbaga point of view kung paano natin ina-analyze yan. No? So instead of saying na the parameter is within this parang normal distribution right here, we are trying to assert if lumagpas na ba siya sa interval. So we are saying na nandito ba yung value na nakuha natin or nandito na ba sa tail na to or pasok pa siya dito sa interval na to. Okay? So, if we go back, no? Ito. So, what that would look like is something like this, no? So if it's a two-tailed test, and later I'll go deeper into two-tailed and one-tailed test. If it's a two-tailed test, then we are saying that there is a critical region wherein we are rejecting our null hypothesis if papasok siya dito sa region na to. Tapos we will accept the null if it is within the interval. So ang analogy again is this is the mark where we find our interval. So in estimation, we are trying to find this interval right here. Pero in hypothesis testing, we are trying to find the, if it's, let's just take the simplest example, no? We are trying to find the, let's say, mean. Then yung z-score yung hinahanap actually natin. So instead of finding yung actual na x values, ang hinahanap natin, and you'll have to go back to your yung probability distributions para mas maintindihan nyo to. So that's why required yung probability dito. So this is the latter part, no, yung z transformation, z score values, yung lesson na yun. So it applies dito, no. So instead of finding yung actual x values where these two intervals lie, ang hinahanap natin is yung z-score values kung saan nakalocate ito parang interval na to. So by doing so, we can determine if pasok ba sa critical region sa yung assertion na ginagawa natin. Okay? So the critical regions will be itong tails na to. So we call this as a tail, no? Itong critical region na to. Tapos if it's a right, that's for the two-tailed test, no? Pero kung one-tailed test siya, then we transfer all the quote-unquote probability doon sa isang region, no? So for example, this is if for example 5% na alpha level 2. So 5% alpha level translates to a 95% confidence level. Okay? Okay, so if this is 5%, so you'll notice na dito sa two-tailed test, naka-split yung 5% na yon sa both tails. So you have, dito P is less than 0.025. So meaning there is a 2.5% probability dito sa tail na to. And at the same time, this is P greater than 0.025. So dito, there's also another 2.5% probability. So spinlit natin siya kumbaga. Now, if we have a one-tailed test, we will combine the two probabilities, no? And this is 2.5, 2.5. Ilagay natin siya on one side. Okay? So, yung buong 5% nandito na. So, you don't have any percentage dito sa left tail. And dito naman sa left tail, wala kang percentage or probability dito sa right tail. Nilagay mo lahat sa left tail. Okay? So, why is it important to have two-tailed and one-tailed test? It's because sometimes you know your process enough that you can determine the directionality of the test, no? So for example, let's take an example like ano no, yung yield strength kunwari. So ang important kasi sa yield strength is that your material is let's just say it's exposed to a particular process no, or a particular application. Pagka lumagpas ka ng certain yield strength value, then ibig sabihin or kunwari yung application mo it experience stresses beyond your yield strength, then you are sure na magfe-fail yung material mo. Parang ganon. So in that sense, alam mo na yung direction na gusto mong i-analyze. So gusto mo it's greater or depending on what you're trying to do no, pero in a way kaya mo nang ma-determine yung direction, either gusto mong greater siya para mag-fail siya or gusto mong less than a particular yield value para hindi siya mag-fail or maging safe siya. So in that sense, meron ka ng directionality sa test. So you do a one-tailed test. Pero there are certain cases wherein um, you don't know the direction of the test. No? Like for example, um, you want to know if kunwari the average na kunwari nagtumakbo kayo sa oval tapos meron kayong average speed na nakuha. You want to know is if yung average speed mo ba as compared to all the people running around the oval is greater than or less than your speed. Parang ganun. So in that sense, hindi mo alam kung ano yung direction. No? You could be higher or you could be faster than the average na UP runner. So pwedeng nandito ka sa right tail or pwedeng nandito ka sa left tail. You are slower than the average. Okay, so because you don't know any direction, then ang mangyayari is you have to do a two-tailed test. So usually, a two-tailed test will be done if you have an equality. No? So if your assertions can be expressed as an equality, then you have to do a two-tailed test. But if your assertion is expressed as a greater than or as an inequality, then one-tailed test yung gagawin natin. And if it's a greater than then if you're testing if your sample yung sample statistic mo is greater than that of the population, then you do a right tail test. Tapos pagka less than naman, then you do a left tail test. Okay? So before I proceed any further, no, let me backtrack a bit and go into the details of what we of the different terms na ginagamit natin for hypothesis testing, no. Okay? So again, hypothesis testing is we are doing an assertion, no, concerning one or more of the population. So it's an assertion, and we are just trying to conclude if this assertion is true or if this assertion is false. Okay, and that this assertion is known as a statistical hypothesis. No, so I think most of you, if you went to a particular na science high school, I think you already have done different parang mga mini research projects, and you might be familiar with itong terms na hypothesis, no. So uh, let's look into some of the examples that on how we can state your hypothesis, no. So for example, suppose that we are metallurgical engineers and we want to know if steel A has a higher fracture strength than steel B. Which is a better hypothesis dito? So we have steel A has a higher fracture strength than steel B, or steel A does not have a higher fracture strength than steel B. Dito, no, and this is one of the ways that kasi there are many ways to state an hypothesis, and in our case, in especially in the engineering, both are acceptable, no? Parang hindi na tayo masyadong concerned dito. Pero if you want to be more accurate about it or more faithful to the purest definition of how to do hypothesis testing, then you need to do hypothesis B, no? So does not have. So ang ano kasi natin is we are just we are not asserting that the hypothesis is true, we are just saying na the hypothesis is not true. Pero um, or based on the data that we have, hindi totoo yung hypothesis natin, parang ganun. So medyo ano no, confusing siya because if something is not true, then it must be false, tama? Pero I won't go into the details of this, pero just try to imagine, no, kunwari lang, um, if you are, kunwari, nasa court kayo, tapos ang sinabi na innocent, yung, wait lang, paano ko ba ipa-phrase to? Yung court example, kunwari nasa court kayo, no? So, we are always innocent until proven guilty, no? So, for example, you are if yung kunwari yung nag-accuse sa inyo does not gain enough evidence to prove that you are guilty, then parang pwede niyang sabihin na you are not guilty, parang ganun, tama? You are not guilty based on the evidence that has presented. Pero the truth of the matter is, pwede ka pa rin na guilty, no? Hindi lang siya nag-present ng enough evidence to show na guilty ka. Okay, does that make sense? So parang ganito din sa hypothesis testing, no? When we are doing assertions, we are not saying na parang based on our hypothesis, or the hypothesis is if we do not have any evidence to show na yung hypothesis natin is not true, then it is false. Parang sinasabi lang natin wala tayong enough evidence to conclude that it is true. So we probably have to do another experimentation. Then if another experimentation hindi pa rin siya true, then that will build on the parang knowledge that we have on the subject matter. So statistics in a way is not absolute, no? Parang hindi niya sinasabi na absolute. Meron tayong absolute na conclusions na ma-arrive, pero we are trying to arrive at conclusions that are statistically significant, no? Meaning if probability yung pagbabasehan natin, it is very improbable that one thing could happen. That's why we for all intents and purposes we accept the other thing. Parang ganun siya, no? Okay? So hopefully that gives you an insight on hypothesis, no? Pero yung meron tayong two types of hypothesis. We have the null, yung tinatawag nating null hypothesis, and we have the alternative hypothesis. So pag sinabi nating null hypothesis, this is the hypothesis to be tested. And yung hypothesis to be tested should always be a should be a neutral na hypothesis, or the status quo. Okay? So rejection of the null hypothesis will lead to the acceptance of the alternative hypothesis H1. Usually null hypothesis is labeled as H0, tapos alternative hypothesis is labeled as H1. Minsan din HA, some books like to place HA, lalo na pagka isa lang yung alternative hypothesis mo. Pero if there are multiple alternative hypothesis, if you look at, kunwari ANOVA has multiple alternative hypothesis, then minsan H1 kasi meron pa tayong H2, H3, ... Okay? Pero for this case, dito naman sa mga cases na i-present ngayon sa hypothesis testing, isa lang, no, yung H0, isa lang yung alternative hypothesis. So we can use H1 or HA. It doesn't really matter, no? Okay? So again, null hypothesis is the hypothesis that is to be tested. Tapos alternative hypothesis is the question to be answered, or the theory to be tested, no? Tapos this is usually expressed as a logical complement to your H0, meaning if kunwari ito, if defendant is innocent ang H0, then the H1 is defendant is guilty. Okay? So ang important dito, class, no, is that H0 should always be a status quo. Okay? So hindi pa rin pagbaliktarin natin tong dalawang to, no? We can't parang hindi natin pwedeng sabihin na yung H0 is defendant is guilty, tapos H1 defendant is innocent. Kasi again, for example, itong in the court cases, we are always innocent until proven guilty. Therefore, yung status quo is innocent yung defendant. Okay? So H not siya. Okay? So in the same manner, let's take an engineering example. Kunwari, no? Um, kunwari, we are trying to assert if yung isang parameter ba, like for example, if temperature, kunwari we're doing a certain process, no? We are trying to assert if temperature has an effect on the yield strength of a material. Kunwari ganyan. So when we are doing, let's just say, an annealing process, kunwari, we want to know if itong temperature ba, pag binago ko yung temperature, binabago ba niya yung yield strength? The null hypothesis would be status quo. Since we don't know anything about the topic, so kunwari lang, we don't know anything about the behaviors, then our null would be yung temperature does not have an effect. Does not have an effect. So that will be our null. Tapos our alternative is, and this is the statement that we are trying to prove. So we are trying to say na based on kumbaga ito yung drive, this is the objective kung bakit natin ginagawa yung experiment. We are trying to prove na temperature has an effect. So temperature does affect naman ang alternative hypothesis. Okay? So usually when we do if we express this in mathematical terms, the null hypothesis will be a inequality. So it's not equal to, while the alternative hypothesis will be an equality, no? Parang equal siya. Pero it depends pala, no? Kasi ito, pwede siyang equal to, pwedeng greater than, pwedeng less than. Okay? So parang ganyan siya. Pero always si H not will be not equal to. So later papakita kung paano natin i-phrase siya in terms of mathematical terms, no, ito. Pero the thing that you must take away from this is that si null hypothesis will be status quo to. This is status quo. Tapos itong alternative hypothesis, ito yung parang assertion na ginagawa nyo. So this is what you want to prove. Okay? So ang conclusion natin dito is always we can reject the H naught. So meaning our evidences show na hindi na status quo yung ano natin. So if we are, kunwari ganyan, always look back at the normal distribution. So parang pwede natin sabihin na kunwari nag-fall siya under dito, then this region is the reject H naught region. Dito, this is the fail to reject H naught. Okay? So when you fall within this region, itong sa tails natin, so whether it's a left tail or right tail, depending on the test you are doing, if you fall within that region, then you reject H naught. So you are saying na you are in favor of H1 or the alternative hypothesis based on the evidences in your data. Okay? So parang dahil dito sa data nyo, kaya nyo nang i-prove na kunwari guilty yung isang tao, or kaya nyo i-prove na si temperature nga has an effect on yield strength. Okay? So that's the conclusion you can make. No? So you can either have this conclusion, or pwede rin if hindi ka pasok dito sa critical region, pwedeng nandito ka sa fail to reject region. So notice how it's fail to reject, no? Not accept H naught. Okay? So ibig lang sabihin dito is you fail to reject H naught because hindi enough yung data mo. And we can look back at the previous example na sinabi ko na we are saying na that the defendant is, we are not accepting that the defendant is innocent. Parang sinasabi lang natin that we are failing to reject that the defendant is not innocent. If that makes sense. Or we are failing to reject that the defendant is innocent. Okay? So, kumbaga, hindi enough yung evidence natin to prove na guilty siya. Ang evidence natin is not enough to prove that it is guilty. Therefore, we fail to reject the assertion. So, meaning, this is the proper way of stating this. Pero, in MMME14, hindi tayo masyadong strict dito, no? Although this is the proper way of doing it, usually ang ano natin is we can just say accept H naught. So in triple ME14, accepting H naught is parang kumbaga acceptable lang sa atin yun, yung terms na yun. Pero if you want to be really accurate about it, you are not accepting H naught, you are just failing to reject H naught. Okay? So dito, yung ito does not affect, okay lang to. Kahit i-state natin siya this way, no? So, okay. So, there are many ways to state na mga H na to, and there are more parang um, faithful ways to state the uh, to state your conclusions, pero in triple ME14 hindi na tayo masyadong stricto doon, no? As long as parang uh, kumbaga ano naman, reasonable naman yung way ng pagka-state, yung kumbaga naiintindihan naman ng parang readers nyo kung ano yung you are trying to convey based on the experiment that you are trying to do, then tinatanggap natin yung mga conclusions na yun. Okay? So later baka mas malinaw siya, no, if we go into actual na problems, no. Right? So now that we know all about the different hypotheses, no, and the conclusions that we can draw from this hypothesis, we now proceed with the approaches for the hypothesis testing, no. So we have two approaches, itong hypothesis approach and the p-value approach. In classical na ano, no, or traditionally yung hypothesis approach talaga yung pinaka parang effective, no, or yung pinaka ginagamit, pero there are more scientists right now that are pushing for the p-value approach. Okay, so let me talk about the difference between the two, no. So parang when you do an hypothesis approach, this is your curve, the normal curve, kunwari ganyan. An hypothesis approach is you are trying to find a test statistic. Okay? You are establishing a critical region. So kunwari ito yung critical region mo. So let's just say Z. So this is Z crit. Tapos and this is your calculated test statistic right here. And let's call it Z calculated. Kunwari ganyan. If it falls within the region, then Z-calc, if in this case, if Z-calc is greater than Z-crit, and kung nasa left side tayo, the Z-calc is less than Z-crit. So dito medyo confusing siya, no, kung nasa left side kayo nakatingin. So that's why in most cases right side tayo nakatingin kasi it's always easier, no, kasi we're dealing with positive values lang dito. Pero essentially they mean the same thing, no? Basta yung Z calculated mo pasok siya doon sa critical region, then we are saying that we reject the null hypothesis pagka we achieve that condition, no? That Z calc is greater than Z crit, or if Z calc is within the critical region. Okay, so that's the hypothesis testing approach. Yung p-value approach is saying na instead of looking at itong Z-crit and Z-calc, ang tinitingnan natin is, kunwari itong Z-calculated natin na ganyan, hahanap tayo ng area nitong that is associated with this Z-calc right here. Okay? So notice the difference, no? Ito, instead of finding itong Z value na to, ang hinahanap actually natin yung P na to. This is the P value. Okay? Now, for it to be inside a critical region, kunwari ito yung critical region natin, ganyan, then the conclusion is yung p-value should be less than the alpha value. So this is usually alpha. And if it's a two-tailed test, then it's alpha over 2. No? If it's one-tailed, then alpha lang siya. Okay? So if this is alpha over 2, and ito din, alpha over 2 din to, then for this particular test to be, for you to be able to reject the null hypothesis, then dapat si p-value should be less than alpha over 2. If it's greater than alpha over 2, kunwari, masyado malaki yung p-value na nakuha nyo, ibig sabihin lagpas na siya doon sa or pasok na siya dito sa parang accept H naught or fail to reject H naught region. Okay? So yun yung difference between the two approach. So essentially they mean the same thing, no? Kasi if you look at it, parang gusto mo lang ang goal mo lang naman is gusto mo malaman if nasa region ka ba ng fail to reject H naught or nasa region ka ba ng reject H naught. So kung nasa tails ka ba or nasa gitna ka ba. Okay? So, yun lang naman the way it's different is the way kung ano lang yung test statistic na kino-compare o kung ano lang yung value na kino-compare mo. Now, why scientists yung mga recent wave of scientists and researchers like the p-value approach is that there are cases wherein kunwari this is a hard parang a hard rule, kumbaga. If kunwari lang Zcrit is let's just say 0.451 kunwari. Hindi ko alam kung accurate yan. 0.451 na lang. 0.451 kunwari ganyan. Tapos ang nakuha mong Zcalc is 0.0450 kunwari ganyan. Kung 0.450 ka, then parang nandito siya, no? It's slightly just before Zcrit. So, ibig sabihin, pasok ka sa fail to reject. Okay? So, fail to reject ka. Therefore, parang yung conclusion mo is as an engineer or a scientist, parang you did not gather enough evidence para to prove that your assertion is correct. Okay? Parang ganun, no? So, 0.0451, 0.04, sobrang, kumbaga, in a way, sobrang late lang naman ng difference niya. So, in some manner of speaking, if you were to have chosen a different alpha value, because this area depends on the alpha value, no? Kung 0.05 siya, mas maliit yung, kumbaga, if you have 0.05, then 2.5% to. Pero if you have something like, kunwari, alpha value of 0.1, kunwari, 10%, then yung area sa left and right will be larger, no? Kasi tig 5 na to instead of tig 2.5. Kumbaga, it's actually 2 times larger. Tama? If kunwari lang ang pinili nyo is 0.1 kasi you start with you always establish an alpha value first, no? Kunwari lang ang alpha nyo pinili ang 0.1, then definitely pasok dapat to sa reject H naught. So magiging conclusive dapat yung evidence nyo. Okay? So, ang kagandahan sa p-value approach is that you just look at the p-value itself. To. So, kunwari, if you look at the p-value approach, kunwari, ang nakuha nyo is 0.05. Let's just say 0.05 ang nakuha nyo, no? 51, kunwari. So, definitely, lagpas siya sa alpha value of, kung kunwari, ang alpha natin is 10%, lagpas siya sa alpha over 2, which is 5%, no? Kasi ito 0.051, that's 5.1%. Pero parang ang sinasabi natin dito, it's parang maliit yung chance na papasok ka dito that there is some level of significance pa rin doon sa results mo. Kaya most scientists like this approach because just by looking at kung if you have a smaller p-value, then ibig sabihin sobrang layo mo na sa kasi I'm not sure if you've already seen the video, no? Yung sinabi ko dati. Kalimutan ko ng pangalan. Pero yung video na sinabi ko, pero it has a good explanation on this parang tailed approach, no? So parang sinasabi kasi natin is, if pumasok ka dito sa itong reject H naught na to, that's saying na parang sobrang unlikely na mangyari lang due to chance itong pagpasok mo dito sa itong maliit na region na to. Kasi unlikely siya eh. Lahat there's a 95% chance na nandito ka and there is only 2.5% chance na nandyan ka sa tail na to or nandito ka sa tail na to. So, kung pumasok ka dito, there is only a 2.5% chance na papasok ka dito if purely by chance siya. So, we are saying, statistics is saying na hindi ka pumasok dyan purely by chance. Pumasok ka dyan because of the evidences or because of the data that you have. Parang ganun siya. So, you can interpret it that way, no? So, parang, therefore, pwede mong i-view it in a different light na parang you can just look at the p-value. Just look at how small the p-value is. The smaller the p-value is, the less likely it is to be due to purely by chance, and it is probably because of the assertion you're trying to make. Parang ganun. Okay. So that's why p-value approach is slowly gaining traction, no? Mas gusto na ng mga tao to kasi um, minsan may ano din to, no? Parang may evil, if I can call it that, evil ba 'yun tawag doon. May malicious na intentions din because sometimes mga researchers, they are pressured to conduct or to have positive results, no? Kumbaga pressured sila na magkaroon ng parang defendant is guilty, or in a way that your parameter has an effect. Parang gano'n, no? Usually kasi pagka maybe those who have ano, no, done researches in their kunwari sa high school nila, sometimes you feel this pressure, no, pagka kunwari ang nang nangyari, ang results nyo is they are not significant. So parang in a way parang sometimes nape-pressure tayo, sayang lang yung ginawa naming experiment, wala palang effect. Parang gano'n, no? Pero we shouldn't treat it that way, no? Because ibig lang sabihin, no, na hindi, kumbaga, kung hindi, wala siyang effect, you are still adding to the body of knowledge, no? Regardless of what results you get from your testing, it's still adding to the body of knowledge, no? Pero the reality of it is, lalo na pagka sa researchers, no, so kaya minsan na nawawalan na rin ng value yung true research is because researchers are ano, no, are pressured to have positive results, or results that are accepting the null that are rejecting the null hypothesis. Okay? So kaya ang because of that, nagiging ano, no, parang sometimes they call it as salting ba yun? Salting the data. Parang sinosalt nila yung data to have positive results. Pero ito din p-value approach is kumbaga nagiging ano na siya, no? Kumbaga flexible na way. For example, 5.1, okay na yan, 5.1%, pwede na yan. Parang ganoon yung dating, no? Ako, I'm not really sure kung ano yung parang ano, no, if it's bad to look at p-value, if it's good to look at p-value. Ako, I like to look at p-value, tapos it makes sense to me na parang if it's smaller, then it is least likely to happen. Tapos if it's a large value, hindi siya pasok dun sa reject null hypothesis. Pero if it's a small value, then parang kumbaga in a way relevant pa rin na i-look in towards, or relevant pa rin na balikan yung research mo. And that is the beauty of research naman, 'di ba? Kasi if we do research, ang goal naman is not to make an absolute truth about something. So when we do research, kunwari ang na-prove mo is temperature does affect uh, the yield strength. Kunwari yun yung conclusion, you know. Research is not saying na absolutely temperature has an effect, no? Statistics and research is saying na interesting na result to, that temperature has an effect. It is worthwhile that future researchers also look into this. Parang ganun. Ganun yung interpretation ng ano, no, ng, or that is kumbaga the culture that research should have, no, that we are not stating absolute truth, we are stating na it because of the results na nakuha natin dito, relevant siya, okay siya na pag-aralan ulit. Parang ganyan. So that's why I like p-value. Pero again, yung statistical purist will tell you na hindi dapat ganun kasi yung statistics is, kumbaga, hindi ka ba dapat bias eh. Wala ka dapat parang bias towards a certain hypothesis. Hindi ka dapat tumitingin kung null, or hindi ka dapat tumitingin kung papasok ka ba dito sa null hypothesis, or papasok ka sa reject null, or papasok ka sa fail to reject null. Blind ka dapat. Wala kang idea dapat sa ganyan. That's why you establish from the start mga critical values, such that para pagka if you do the testings, if you fall beyond or within the critical values, then that's purely because of statistics. Wala kang kinalaman doon. Wala kang bias involved. So the purist don't like p-value. So ayaw nila itong p-value approach, no? Gusto nila itong hypothesis testing approach kasi ito kumbaga hard talaga siya na if you have a critical value, you are blind to any biases. If you go outside, you fall inside, it's because of statistics alone. Okay? So yun. Pero if you use p-value in the same way that you use hypothesis testing, no? If you look for example ito, kunwari you do a hard na limit which is itong alpha value natin is 0.05 kunwari or 0.025 dahil half siya, then you could still achieve the same kumbaga rigor na na-achieve ng hypothesis approach. Okay? So, medyo nag-rant na ako doon, no? Pero hopefully natulungan kayo sa kunwari nag-future research na kayo class, no? You must keep this in mind, no, na sometimes it's tempting to always look at a positive result. So kailangan din i-ano nyo, no. Kumbaga you need to ano bang term doon? You need to be careful in those types of assertions, no. Anyway, so yun yung p-value approach. You can do p-value, you can do hypothesis testing, and ito yung mga steps na kailangan nyo i-take. No? So again, state the null and alternative hypothesis. Null is status quo. Alternative is the assertion that you're trying to make. Then you choose a fixed level of significance. Hindi mo pwedeng balikan siya, hindi mo pwedeng bawiin para to get a favorable na result. So kailangan kung ano yung sinet nyo, yun na yung because again, unbiased dapat to. It should be an unbiased. So you fix the level of significance. Usually we choose 5%, no? But sometimes again, pwedeng alpha can be 1% or 10%. So 5% corresponds to 95% level confidence level. 1 is 99% confidence level, and 10 is 90% confidence level. Okay, then you choose an appropriate test statistic and establish the critical region based on the test statistic. This test statistic right here is based on kung ano kumbaga yung tinatry natin i-assert, no? So it's either let's just say pwede siyang t value, pwedeng z value, pwedeng f value, and it depends on kung ano yung test statistic na ginagamit natin or yung ina-estimate natin or yung pinoprove natin. Like for example, if it's a mean, you use the z. Ito yung test statistic natin. If it's let's say variances uses the f value, no? It's at t value usually pagka this is the student t value if the population is unknown, no? Yun yung normal case na ginagamit siya. We also have, let's look at other dito, no? We also have f values. Where is the f value? We have a chi-square value as well. Some of you might be familiar with this, no? Chi-square. This symbol here is chi, no? So chi-square. Then we also have these are the statistics, no? Ito na dito. Chi-square, and where is the f value? Yan. Meron tayong f value din dito. Chi-square and f is for variances or standard deviation. T is for means, and z for means din as well. Okay. So after getting the test statistic and establishing a critical region, you compute for your test statistic, and this is the calculated value. No? So if it's a z, then we have z crit and z calc. So you compute for both. No? Or if it's a t, then t crit, t calc. Okay, and so on and so forth. So once you establish, based on this two values, pwede ka nang reject the null hypothesis or fail to reject the null hypothesis. So again, you can always look at the right side lang, no? So z crit is greater than if z calc is greater than z crit, reject null. Ito yung natin. Sometimes ang more parang para mas general yung itong statement na to, minsan they state it this way, no? If z cap yung if the absolute value of the z calc is greater than the absolute value of the z crit, then we reject null. So kaya effective to kasi kahit nasa left tail ka, mag-work pa rin naman to kasi let's just say ito, no, kunwari lang 2 point negative 2.31 to. Dito sa right tail, that's 2.31. So if you take kunwari yung z na nakuha nyo, yung z calculated is negative 2.5, then if it were translated into the positive kasi symmetrical to, positive 2.5 yun. Okay? So that's why dito mag-work pa rin yung itong absolute values, no? So if you want, para hindi kayo ma-confuse, lalo na pag meron kayong mga left tail values, no, that involves negative, just think of this equation right here. If z-calc is, the absolute value of z-calc is greater than the absolute value of z-crit, then you reject h naught. Okay? Pero ang suggestion ko parati class, just draw the itong normal distribution, no? You will by drawing the normal distribution, you can imagine it if pasok siya dito sa critical region or within the parang interval siya. So if within the itong siya 95%, then we fail to reject. Tapos pag pasok siya critical, then we reject. So that's my suggestion. No? Pero again, it depends on how you want to interpret it. So dito sa hypothesis approach naman natin, as a p-value approach is the same as the hypothesis approach, so halos the same. Pero instead of you calculating for the yung z-calc, instead of calculating z-calc, t-calc, etc., you just calculate the p-value. No? So the p-value, once you get the p-value, ay actually from the z-calc pala, i-translate nyo siya into a p-value. So there is no need to compute for t-crit. Yung mga t-crit, z-crit, so no need to compute for the critical value. Because once you get the p-value, i-compare mo siya directly into the alpha value. Now dito, opposite naman, no? Since itong mga p-values naman natin is an area, no? So it's always positive. So there is no other interpretation dito, no? So if p-value is less than your alpha, then we reject h naught. Okay? So dito, dapat lumagpas si z-calc sa z-crit para ma-reject. Dito naman, dapat less than the alpha value para ma-reject h naught. Okay? So, minsan ito confusing to class, no, kasi and later papakita ko na lang sa Excel kung paano mo maano yung confusion. Pero si p-value kasi ang problema dito is that sometimes yung half value yung kinukuha, lalo na pag two-tailed test. Ito sa two-tailed siya usually na nagkakaproblema, no? So kunwari ganyan. So kunwari nang nakuha nyo dito is half the p-value, then and you compare it to the alpha over 2 kunwari. Pero ang nakuha mo p-value is actually kunwari full p-value siya, no, na both sides. Pero tinry mo i-compare sa alpha over 2. So mangyayari is posible na magkaroon ka ng false rejection or false failing to reject, parang ganyan. So you need to be careful class, no, kung alpha over 2 ba siya or alpha talaga yung i-compare mo. And later, ipapakita ko sa Excel. So, hindi ko na ipapakita yung mga, yung normal way of doing it, no? Yung using tables. Hindi ko na siya ipapakita. I'll leave this up to you guys to work on your own. But I'll be showing yung mga the spreadsheet way of solving these things, no? Okay? So, yun. Yun yung two approaches. Now let's try different cases naman, no? Let's start with test on a single mean muna. Okay? So ang analogous case nito sa test statistic is that you or sa parang confidence interval is you are trying to find x bar plus minus a certain error value. Okay? So yun yung or margin of error. Sometimes we call this as margin of error. Okay? So instead of finding the interval, gusto natin malaman kung yung single mean ba is equal to the population mean. So ito yung, this is how the null hypothesis is stated. So mu is equal to mu naught. Minsan din sinasay siya as x bar is equal to mu naught. So parang sinasabi dito na equal lang sila. Now, a possible alternative hypothesis is, depending on the type of test involved, is pwedeng mu naught is not equal to, si mu is not equal to mu naught, or si x bar is not equal to mu naught, meaning yung sample na nakuha mo is not representative of the population, or that the sample that you got actually is larger than the population, or pwede ding sa left tail, the sample that you got is less than that of the population. Okay? So, for your single mean, ang ginagamit natin dito is si Z, no? Z values. Now, let's take this example right here. So, meron daw tayong random 100 recorded deaths in the United States during the past year. And it showed an average lifespan of 71.8 years. Assuming a population standard deviation of 8.9, does this seem to indicate that the mean lifespan today is greater than 70 years ago? Okay. So, sorry, that the mean lifespan today is greater than 70 years. So parang ito yung population na 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 mean na gusto natin i-prove. So, solution natin dito is that we state the null and alternative muna, no? So, we are saying that the mu is equal to 70 years. That's our status quo, no? We are saying that there is no difference. Tapos, the alternative, kasi the question is stated as, does this seem to indicate that the lifespan today is greater? So, kaya one-tailed test yung gagamitin natin. If the statement was said like, does this seem to indicate that the mean lifespan today is not equal to 70 years, then pwedeng is not equal to yung ginamit natin. So we can do a two-tailed test. Okay? Pero ito obvious naman kasi itong 71.8 naman is obviously greater than 70, no? So parang useless na i-two-tailed mo pa to. Mas useful kasi we know the directionality of this. It's more useful if we, kasi kumbaga if you do a two-tailed test, instead of a one-tailed test, parang quote-unquote nasayang yung area dito. So yung area na to to make the more kumbaga para mas accurate sana or mas rigorous or ano bang mas stricter in a way of if in a manner of speaking, no, para mas strict yung isang test, dapat mas malaki yung area na kina-cover niya. Okay? So or tama ba yung term na strict? Parang mapangit ata yung strict. Parang ano bang, I can't find the exact term, no, pero hopefully you get the point, no, parang if nilagay ko siya dito, yung tail, nilagay ko ng tail dito, pero I already know that I am trying to prove na alam ko na yung term, mas sensitive, kumbaga. Kung gusto ko mas sensitive yung test ko, dapat ilagay ko tong yung tail na to dito because I know na yung I'm trying to prove na itong 71.8 is greater than 70 years. So notice dito, less sensitive siya, no? Kung kunwari lang hindi ko nilipat, nandito pa rin siya, two-tailed test pa rin siya. You'll notice na mas less likely na kunwari meron ako nakuhang value na nandito siya. Let's just say, let me erase that. Kunwari lang, ang nakuha kong T calculated is this one. So, if I have a sensitive na test, the one-tailed test, pasok ako sa region ng critical region and therefore I can reject the null hypothesis. Pero if I didn't do the one-tailed test, I did a two-tailed test instead, ang mangyayari is hindi ako pasok sa critical region na yun. So that in that way, parang hindi sensitive yung test ko na ginawa dahil pinilit ko i-two-tailed siya when in fact it could have been just a one-tailed test. Okay? So ito, one-tailed test natin to. So let's use almost always yung 0.05 yung ginagamit natin, no? If it's not stated, it's a problem, then just use 0.05. If it's stated in the problem, then you use the whatever is stated in the problem, no? So ito, 0.5, we can get it from the table or we can do, I don't know, Excel. So try natin sa Excel, no? Ano ko to? Let's do half. So, meron tayong, anong tawag dito? 70. We are looking for the Z value, no? Wait. We are given 71.9, tapos meron tayong 70 years, tapos sabi daw given din tong standard deviation, no? So we can actually do norm dot s dot dist. No, sorry. Norm dot dist, and our x is 71.8. Our mean is what is our mean? 70. As a standard deviation is what is our standard deviation? 8.9. And we do probability mass. We do false, no? Kasi hindi naman natin ano, kumbaga we are looking for yung, tama ba? Wait lang, 0.048. Let me double check last, no? Nakuha niya is Z value na nakuha niya. So ito kasi ginamit nila, no? Wait lang, norm. Okay. I should have used norm.in, no? So pag norm.dist, you are trying to find for the hinahanap mo yung ano, no, yung area. So actually this is the p-value approach. So let's do yung critical value muna. So if you want to find the critical value, then you just do norm.inf. Okay? So you have the probability, tapos pwede mo ibigay yung mean and standard deviation. Or kung gusto mo, pwede ring norm.s.inf. And that is norm.s.inf is like saying S again represents the, I don't know, when we say .s.inf, ang sinasabi natin dito is we are doing a standard na normal distribution wherein if you remember standard normal distributions, pag standard, parang sinasabi natin na itong x in the middle is equal to 0, tapos each standard deviation is plus minus 1. Parang ganyan. 2, 3, negative 2, negative 3. Okay? So, if you want to look it up like the ones here in the table, then we can very much well do that. No? So, if you do norm.s.inf, and our probability is, this is a one-tailed test, no? So, we can do 0.05. So we don't divide it by half kasi one-tailed siya. So we can do, we can have something like negative 1.68. So kaya siya negative kasi ang nilagay ko is 0.05, no, which means na dito ako kumuha. So this is a right-tailed test. So since this is a right-tailed test, then instead of using 0.05, ang gagamitin ko is 0.95. Okay? So this is my Z-crit right here. See, 1.64. Okay? Which is the same as nakuha niya, no? Although nakuha niya is 1.645, which is fairly close naman sa ano ko, no? Kasi ito naka-round up na siya. Ito 644. So if we do 3 digits, 1645, same lang naman sa nakuha niya. Okay, so that's how we do Z-crit. Tapos we can compute for our Z calculated, no? And Z calculated is given by this formula right here. So that's z calc is equal to x bar, which is, I think I can do z. Inisip ko kung kaya ko ba mag z transform using norm.dist. Kasi kung norm.dist, hindi, makukuha ko kasi yung, anyway, sige, okay lang to. So if we do x bar natin is equal to 71.8. 0.8 na ba yun? 71.8 minus 100 divided by yung standard deviation, which is 8.9. Tama ba? 8.9. 8.9. And 8.9. Tapos 8.9 divided by, ano no. So we can do divide ganyan, or pwede ring ilipat na lang natin sa taas, no, kasi MDAS naman to. So we can just multiply it by 8.9 times square root. Square root is SQRT, no? Square root of the number of samples, which is 100. Tama ba? 71.8. Ano? Bakit 100 to? Minus 70. So you get 2.02, which is the same value na nakuha siya dito, no? Nakuha niya dyan, 2.02. Now, since you have zcalc and zcrit already, then you can have your conclusion, no? So you can do, since zcalc is greater than zcrit, then we reject h naught, and therefore you can make your engineering conclusion, no? Your conclusion is the average, since you are rejecting the ito pala yung ano niya, norm.s.inf. Nakasulat naman. Hmm. So, ang conclusion natin is the mean life today in the United States is greater than 70 years old. Okay? So, if we were to complete the steps, so let's just say na i-complete natin siya, no? So, if we state our alpha is 0.05, dapat nag-state tayo ng null. Add lang tayo, no? I-larger ko lang to. We state our null hypothesis. H naught is the mean life today is not is equal to 70 years old. Tapos H1 natin is the mean life today is greater than 70 years old. Pwede rin, instead of stating it this way, pwede rin ginawa natin is mu is equal to 70. Mu is not equal to 70. And this is usually this is how the programming language states inequalities, no? You put a exclamation point before the equal sign. So that indicates na is not equal siya. So mu is not equal to 70. Pwede rin, if you don't like placing mu, pwedeng u na lang ilagay nyo, which is parang pwede natin assume na mu yan, no? So I just like to place mu, or pwede rin if you're feeling adventurous, search nyo yung mu character, tapos kopyahin nyo siya, mu, pwede rin yan. If you want to be, kung nauusi kayo, no, pwede naman ganyan. So yeah, you can do that. Mu is equal to 70, mu is not equal to 70. Okay, so that's how you do hypothesis testing for single means lang. So dito sa single means, we are saying na is the mean comparable to a certain value, established value. It could be a population parameter or a known parameter, no? Okay? So yeah. So if you were to do the p-value approach, and ilagay ko na lang din yung p-value approach dito, no? So the p-value approach is we do z p-value. So p-value is computed as norm. We can compute it through the z-calc or pwede ring i-compute natin through the given values. No? So let's first compute it through the z-calc. If you do norm.s.dist, .inv, dist dapat, of the z value, which is ito. And but take note, this is the right tail, no? And we need the cumulative value true. Magma 1 minus pa tayo. Kasi ito, we are looking at it from the left side, no? So the si Excel kasi they always compute, lahat ng mga cumulative nila is always read from left to right. Tama? Parang ganyan. If you were to draw it, if this were the it's always, kung cumulative ka, it's always from left to right. So parang pa ganyan. So ito yung kinocompute niya. So from the Z calculated na 2.022. Pero what we want is p-value, no? And this is the p-value here. Itong area na to. So kaya natin wina 1 minus norm.s.dist. So you get 0.021. Okay? So pwede rin, we can make the same conclusions, no? Parang since p-value is less than the alpha, and if you want to place the p-value itself, pwede rin i-enclose siya ng ganyan. Pero hindi na siya necessary, no? So since p-value is less than alpha, then we arrive at the same conclusion, no? Reject h naught pa rin siya. And therefore, our final conclusion would be the mean life is and pwede rin siguro kasi okay na yan. Okay? Now let's do another approach, no? When we do norm .inv, we take norm.dist ng x natin. We can do x is 70. X is 71.8. Tama? Tapos mean is 70. Standard deviation is 8.9. Cumulative, again, read from left to right to, no? So 1 minus pa rin tayo. Parang ganyan. And you should get, wait, bakit magkaiba sila? Nakuha ko yung wait lang class ah. This should be the same value. Wait lang, kunin ko lang yung 0.58. So hindi siya cumulative. Wait, let's investigate kung anong ibig sabihin nga ng cumulative. Cumulative, logical was returns the cumulative distribution. If false, it returns the probability, the density function. Wait lang. Kasi kung non-cumulative siya, ang makukuha ko dapat dito, oh, 0.4. Hindi magkaiba din eh. Anyway, wag na muna natin gamitin yung function na yan. Mas maganda kung norm.s.dist na lang, no? I could probably show it to you pagka na-figure out ko yung no. Kasi alam ko pwedeng i-direct input siya eh. Pero anyway, okay na tayo dito sa single means lang muna. Okay? So, next is let's try another example, no? Proceed na tayo sa next pala. Sorry. So single mean, medyo confusing pala ito. No? Itong case 2 naman. So case 2 natin is when we have an unknown population. No? So dito, yung unang pinakita is known yung population standard deviation. Ito siya. Known siya, no? So it's already given and it's known population standard deviation because binigay naman yung 8.9 years. Okay? Now let's look at an example wherein unknown yung population standard deviation but the sample size is large enough such that we can assume normality. No? So the rule of thumb is that if the random sample size is greater than 30, then we can assume normality and therefore pwedeng case 2. But if it's less than 30, then we need to use case 3 in that case. Sa ang difference lang ng case 1 and case 3 is that magkaiba yung test statistic, no. In case 2, we still use Z, pero sa case 3 we use the student t value, no, the t. Okay? So let's try this one. Ito, I'll just label this as case 1. Lagay ko naman dito case 2. So let's try this example case 2. So in the Edison Electric Institute claimed that a vacuum cleaner uses 46 kilowatt hours per year. So if we get a random sample of 12 homes and included in a planned study, and it indicates that the vacuum cleaners use an average of 42 kilowatt hours per year with a standard deviation of 11.9, does this suggest that at 0.05 level of significance that the vacuum cleaners use on average less than 46 kilowatt hours annually? So in this case, meron na tayong mga clues agad, no? Less than, ang assertion niya is less than, so there is a directionality towards it. So therefore, dapat one-tailed test yung ginagamit natin dito. Now the next one is 12 lang daw yung samples, no? So if it's 12 samples, then this is actually case 3, tama? Kasi si case 3, if you look at case 3 indicates that the sample size is small. Tama? So unknown din yung population standard deviation dito, tama? Ang binigay kasi na standard deviation is the sample standard deviation. So this is the standard deviation from the 12 homes na kinuha nila. So that is different from the population standard deviation. No? So because it is a small number, case 3 yung gagamitin natin. So let me just relabel this. No? Case 3 dapat to. So let's do this. So first is hypothesis muna tayo, no? H naught and HA. Yung null natin is how would you like to state it, class? Gusto ba natin yung parang mathematical way or gusto ba natin yung parang in terms of parang words or phrases? Kayo, words. Shane likes words. Yung iba, ano yung yung iba gusto ng math, no, kasi mas madali siya. So let's do both na lang para mas to satisfy everyone. Pero kayo pagka kunwari during mga exams, yung sa mga modules, no, if it requires na although sa hypothesis testing module naman natin, I think hindi naman nire-require na kayo yung gumawa, no. Doon sa assessment natin. Pero in case na pinapa kayo dito, you can actually use either way, no? So pwedeng yung math way or yung ano. So dito, yung math way, H not always an equality siya. So therefore, yung sinasabi natin is yung mu natin, mu is equal to yung mu naught. Ganyan. Or parang sinasabi natin dito, 42 is statistically equal to 46. Okay? So which might not make a lot of sense sa inyo class, no? Kasi how is 42 equal to 46? Sobrang iba naman yan eh. Pero take note na etong mu kasi etong 42 na to is an estimate, no? So parang sinasabi nila na yung estimated na 42 na nakuha with the taking into account yung mga parang standard deviation niya of 11.9 kilowatt hours is statistically equivalent to 46. Okay? So, Okay, yan, tama si Shane, no? It's within the interval, kumbaga. Yung 42 plus minus something is within the interval of 46. Parang ganyan. So, para hindi kayo malito, tanggalin nyo na lang yan. Mas maganda kung i-state nyo this way, no? Mu is equal to mu naught. Okay? Tapos, yung next natin, yung H1 natin, mu is less than mu naught, no? Tama? Mas maganda ba kung ganito or mu underscore? Ganyan siguro para. Or, kinopya ko pala yung mu symbol, no? Yan na lang. Mu naught. Mu naught. Okay? So, that's mu is equal to mu naught and mu is equal, ito, we are saying na the ang sinasabi dito is the vacuum cleaners use on average 46 kilowatt hours per year. Okay? So that's the equality. Tapos the vacuum cleaners use on average less than 46 kilowatt hours per year. Kilowatt hours per year. Okay, so that's how you state. This is the mathematical way of stating it. This is the parang where if you use phrases, no. So, use on average, tama ba to? If you want to be more accurate, pa rin namang the vacuum cleaners from the 12 homes. Pwede ganun yun. Use on average 46 kilowatt hours. Tapos the vacuum cleaners from the 12 homes. Pero in most cases understood na you're talking about the sample, no? Yung sa from the 12 homes. So pwedeng hindi nyo na isama itong from the 12 homes. Let's just add it for accuracy, no? Okay? So we established H naught and alpha, H naught and H1. Then we establish alpha, no? Alpha is equal to 0.05. Sabi dito 0.05. So now we get the Z-crit and Z-cap. And lagay ko na rin yung p-value, no? Para may two ways kayo of solving it. Pero again, you only need to choose one. Okay? So let's compute for, T-crit and T-calc na yung kinakalculate natin dito. Kasi this is a small sample size. So let's do T-crit. T-crit is equal to T. And dito sa T, when you use this, ang kinukuha natin is, kumbaga, i-return natin yung student's T distribution, yung T value yung i-return natin. When you use INV, kung every time you use the INV, yung mga, and this applies to every test statistic, no, whether it's F value, T value, P value, chi-square value. Pagka sinabing INV, hinahanap nyo ay probability. Okay? Sorry. Baliktad. Pagka T dist yung hinahanap nyo, probability yung i-return sa inyo. Pagka T.INV yung hinahanap nyo is yung test statistic yung hinahanap, yung kukunin nyo. So kumbaga, if this is your probability distribution, if you get the INV value, ang i-return sa inyo is itong T-crit na to or whatever test statistic. Pag ang ginamit nyo is, this is from T.INV. Pag ang ginamit nyo is yung dist, ang i-return sa inyo is yung probability under the curve. Ito. So, yung dist, if you use T.dist. Okay? So, and if nalilito kayo, malalaman nyo naman siya pagka, kunwari, tinype nyo lang, no? Kunwari, T.INV. Pag tinype nyo T.INV plus probability ang hiningi, therefore, ang i-return niya is yung critical value. Tapos kung kunwari sa dist, if you look at this, ang hiningi sa inyo yung X value or yung T value. Therefore, ang i-return niya is probability. So, that is parang a quick and dirty way to remember it, no? If you get confused with inv and dist. Okay? So, since ang hinahanap natin is secret values, and then we do T dist, no? we can do t-dist. If it's just t-dist, ang sinasabi dito is it's from the left tail. If lalagyan natin ng dot 2t, it's a two-tailed probability. Pag nilagay ng RT, this is a right-tailed probability. Kung kumbaga na-measure niya from the right. So, from infinity going to the left. Parang ganyan. Okay? So, since ang ano naman natin is from the left tayo, no? Kasi left-tailed test to. We are looking at is less than siya. Mu is less than mu naught. Then therefore, t dot dist lang yung gagamitin natin. Okay? So that t dot dist. Tapos yung x value natin is wait, bakit t dot dist yung gagamitin? T dot inv, sorry. Kasi ang hinahanap natin, sorry. Secret pala hinahanap natin. So, t.inv yung gagamitin. So, t.inv, and we are looking at, again, same applies, no? Pwedeng 2t or pwedeng left-tailed or 2t yung gagamitin natin. So, let's just use the left-tailed, no? Kasi this is a one-tailed test. So, all of the 0.05 will be nandito sa, sa left side. So, ang degrees of freedom natin is equal to degrees of freedom for for the t test is equal to itong term nga to. This is nu. Nu nga ba? Nu Greek. Yeah, this is nu. Okay, so this is the nu value, no? Nu. So the new value is equal to just n minus 1. So in this particular case, since we have 12 homes, ang new value natin is 11. Okay? So you have a T critical of negative 1.796, which is the same as dito no? 1.976. So ang T calculated natin, also, ito pala class to, if you, kunwari lang, gusto niyo ipilit yung t.inv.2t, you actually have the same value if you input t.inv.2t, tapos ang ilagay nyo, instead of using 5%, kasi you are trying to imagine na yung buong 5% na sa left side, pwede actually ang gawin nyo is 0.1. Tapos degrees of freedom is also 11, and you will get the same value, no? Pero sa 2T, always positive yung lumalabas. So, kung gusto nyo always positive, pwede naman 2T na lang ilagay nyo. Tapos, depending na lang on how you visualize, kunwari ganyan. So, if you look at, kunwari ito, in this particular case, 0.05 is, all of the 0.05 is nandito. So, para ipilit nyo yung two-tailed. So, kung two-tailed sa 0.05, then dapat sa two-tailed may extra 0.05 pa dyan. Kaya 0.1. So, pwede nyo, kumbaga, in a way, ano nyo lang, no? I-work around nyo yung system. So, pwedeng ganun, no? Pero, if you don't want to be confused, then you just use t.inv.0.05. If you want to get the positive value, kunwari, you need the t.inv, pero gusto mo positive na lang lumabas para hindi ka na mag-absolute value, pwede naman, instead of inputting negative, instead of inputting 0.05, input mo 0.95. 11, and it will give you the same value, no? Nasa right side naman siya. Okay? So, three ways of going about it. Ito yung pinaka-accurate, no? Kasi this signifies na sa left tail siya kasi negative siya. So, mas madali siyang ma-imagine in terms of looking at the probability distribution. No? Pero, in terms of parang actually making conclusions, it's always just easier to look at the positive values, no? Pero it's fine. We will just do it this way, no? So T calculated natin, the T calculated is equal to this value right here. Ito. X bar minus mu naught over sigma over square root of n. So it's actually the same as, no? Same lang siya doon sa Z transformation, pero instead of using the mu naught, the population standard deviation, you use the sample standard deviation. Okay? So dito, let's type in ano ba yung binigay? It's 42 equals 42 minus 46 divided by our standard deviation, our sample standard deviation is 11.9, and multiply that by square root of 12. Tama? So, notice again, class, minultiply ko na lang diretso, no? Pero technically, this should be, if you follow the formula strictly, no, parang ganyan dapat siya. Pero again, since naka-MDAS naman si Excel, I can just put the square root up sa task, no? So, it's just easier, no? Mas madali siyang, ano. Pero if you get confused, then you just do the, itong parenthesis, no? I-parenthesis nyo na lang itong denominator na to. Okay? So, let's do that. That gives us 1.164, which is the same, no? Ito. So, let's check if nasa critical region siya. So, pwede nyo i-visualize, no? Parang ganyan. So, this is negative 1.79 right here. Dito si 1.79. That's our critical region. Tapos, yung T calculated natin is bitin siya, no? Nasa fail to reject region pa rin siya. Dito siya. So, pwedeng gawin natin is, para less confusing siya, gawin natin, mamaya. Since T calc, and let's use absolute value, since the absolute value of the T crit is less than the absolute value of T calc, sorry, the absolute value of T calc is less than the absolute value of T crit, then we reject, then we reject H naught. Okay? Now, let's try the p-value approach as well, no? Lagay na rin natin p-value. So, if you want to get p-value, we're talking about probabilities dito, no? So, instead of finding T-INV, ang gagawin natin is T-dist naman. So, we can do T-dist. The X value is ito. Itong T-calc na to. Our degrees of freedom is we have 11, and cumulative yung gagawin natin. So we have 0.135. Okay? So we could also do T dot this dot RT if you want to get if you get the positive value nito, no? So kunwari lang i-positive value natin to. Tapos degrees of freedom 11, you should get the same value, no? Kasi symmetrical naman yung distribution. Okay? So ayan. Okay? So you can do T this ganyan ng negative value kasi this is the left tail, or you can do T this dot RT ng positive value nitong T calc. Okay? It depends on you guys kung ano yung mas comfortable kayo. But this just says that there are many ways to solve it, no? And ang kagandahan din dito, guys, no, na marami kang yung ways to solve it is that marami din kayong ways to check if tama yung nakuha nyong sagot. Okay? So with that said, pwede nang i-input din natin since P, and let's just say P na lang siya, no, para mas madali instead of P value. Since P is greater than alpha, since P value is greater than alpha, then we reject H naught. Kasi again, opposite si conclusion ni P value, no? Kung mas maliit siya, tsaka tayo nagre-reject alpha. Ay no, we fail to reject. Sorry. Bakit reject alpha to? Fail to reject H naught. Fail to reject H naught. So therefore, ang mangyayari dito is ang conclusion natin is that the vacuum cleaners, copy natin ito. Therefore, the vacuum cleaners from the 12 homes use on average 46 kilowatt hours per year. Okay? And same ba tayo ng conclusion? Pwede rin ganito yung pagka-state nyo. This is also another way of stating it. Para sinasabi niya na you're failing to reject your assertion. No? So, sorry. You are failing, you are not accepting your assertion. Therefore, para sinasabi niya, hindi significantly less than 46. That's also another way of stating it. No? But I think this is already accurate enough. No? The vacuum cleaners from the 12 ohms use on average 46 kilowatt hours, which is the, I don't know, the established na parang true value niya. Okay? Or the true parameter. Okay? So that's case 3. Now let's proceed. Medyo i-ano ko lang class na hindi tayo mag-break kasi kulang na yung oras natin. Dire-diretso na lang tayo. Okay, so that's for single means. Proceed naman tayo sa two means, and for two means, meron din siyang four cases, no? Similar to the single means, no? So meron tayong case 4, case 5, and case 6. And itong mga cases na to are similar din. So known variances, unknown variances but equal, at saka unknown variances and unequal. Okay? So meron tayong two data sets na binigay, tapos gusto natin malaman if equal ba yung data sets na meron tayo or yung means ng data sets. So usually mas kumbaga itong mga cases na to is applicable to comparison of two things. So it could be kunwari comparison of the performance of two materials or the performance of two products, parang ganun. Or you want to know mga performance of two companies, mga ganyan. So whenever you have a comparison, um, you will need to do comparison of two means, no? Itong case 4, 5, and 6. So let's try this example right here. Meron daw tayong experiment that was performed to compare the abrasive wear of two laminated materials. We have 12 pieces. 12 pieces of material 1 were tested by exposing each piece to a machine measuring wear. Tapos 10 pieces naman of material 2 were similarly tested in each case. In each case, the depth of wear was observed and the samples of material 1 gave an average wear of 85 units daw with a standard deviation of 4. Tapos sample 2, 81, 81 naman sa kanya yung units. Tapos standard deviation of 5 naman. So can we conclude at the 0.05 level of significance that the abrasive wear of material 1 exceeds that of material 2 by more than 2 units? So let's assume that the populations be approximately normal with equal variances. So kung equal variances siya, so the variances are unknown, no? Kasi wala namang binigay na variances ng mismong na population variance ng material 1 and material 2. So they are unknown variance and sinabi naman na you can assume it to be equal, no? Okay? So dito sa class, no? Sa etong si unknown variances, pwede actually tingnan nyo siya. Meron siyang D naught value, no? And in most cases, D naught is just 0, no? So, kumbaga kung nagko-compare kayo ng two means, usually we are saying na X bar 1 is equal to X bar 2. Ganyan. Or they are not equal. Pwedeng alternative is that they are not equal or that 1 is greater than 2. And lastly, pwede ring 1 is less than 2. Pwede ganyan, no? But at the same time, yun yung kung if D naught is equal to 0, no? Parang ganyan. Pero if you are testing for, kunwari, parang gusto mo ma-prove na one is greater than the other by a certain amount, then you can actually place D naught value, no? Yung kumbaga, yung tested na difference between them. So D naught. Okay? So ito yung mas general, no? Where you have D naught. Pero you can always assume na zero sila if you are just testing for equalities and inequalities, no? In this particular example, gusto kasing i-assert yung assertion natin is that merong difference sila of more than 2 units. So dito, there is also directionality, tama? If you look at it, then we conclude that where material 1 exceeds that of material 2 by more than 2 units. So kumbaga, ina-assert niya na si material 1 is greater than material 2 by a factor of or by more than 2 units. No? Okay? So, ibig sabihin nun, let's state that. So this is, again, important class now when we're solving these types of problems, you try to determine kung ano yung cases na involved. So in this particular example, based on the data na nakuha natin and how it is stated, we have found out na case 5 siya. So if you guess the case wrong, ang mangyayari kasi dyan is pwedeng magkamali kayo ng sagot. Okay, so ilagay natin dito case 5. Sorry. Dito pala. This should be case 5. Okay. So let's type in our H naught. So our H naught is, we are saying na si X bar is greater than, so si X1 natin is greater than that of material 2 by more than 2 units. So para sinasabi natin X bar 1 minus X bar 2 is greater than, is equal to 2 muna. Tapos si HA natin is X bar 1 minus X bar 2 is greater than 2. Okay? So that's how we place our inequalities, no? Pwede X bar, pwede rin if you want, we can use the mu value, no? So pwedeng gamitin natin itong si mu. Mu1, mu2. Pwede naman ganyan din. Okay? So so pwedeng ang ano dito is the material 1 abrasive wear is not more than 2 units greater than that of material 2. Tapos ito naman, material 1's abrasive is more than 2 units greater than that of material 2. Okay? So, pwede natin i-solve siya, no? Kasi ang mahirap dito sa ano, meron kasi siyang, kailangan mo i-compute itong pooled standard deviation, no? Which has a long formula. So you can do that. Pwede natin i-solve siya. Pero I'll teach you a quicker way of solving this, no? And it requires that you enable your actually pwede atang say yung long method muna. We can do t-test. Hindi kasi binigay yung dataset. So we are not able to do this. Sige. So mukhang ang best way to solve this is to and I suggest that from the start, no, enable nyo na siya. So ito, when you go to file, you go to options, then you go to add-ins, tapos i-add nyo tong Excel analysis toolpak. Ito, analysis toolpak. So yan. So if you go to go, dapat i-enable nyo siya. Naka-tick dapat siya dyan. Kung naka-tick siya dyan, dapat pag tinignan nyo yung data nyo dito na tab sa taas, may dadagdag dapat na itong analyze na ano, no, na group. And this is where you can find the data analysis toolpak. Okay? So hopefully lahat kayo naka-enable na si data analysis toolpak, and actually sobrang dami ng pwedeng gawin dito, no. So meron siyang ANOVA, may correlation, covariance, descriptive stat. Meron din siyang exponential smoothing, F-test, sobrang dami, no? So, ito, medyo ano siya. So, I think more of yung iba nakagamit naman ng ganito. Tapos may, tama si, ano siya, no? May mga instant tables na lumalabas dito. So, we can use this, no? So, dito, this is a comparison of two means, no? So, this is actually a t-test that assumes two sample assuming equal variances, unequal variances. So ito, we are assuming, are we assuming equal variances? We are assuming equal variances. No? So pwede nyo t-test, two sample assuming equal variances. So you click OK. Meron ganyan dyan. So meron siyang variable 1 range and ay, hindi pwede. Kasi it requires that you have a range. No? Dito kasi walang binigay na data set. So parang yung t-test lang din pala to. It requires kasi na meron kang data set. Pero dito, ang ginawa niya is meron na siyang, kumbaga, hindi na binigay yung data set. No? Ang binigay na ang mismong average pati yung standard deviation. Okay? So, mukhang hindi natin magagamit pala to. So, we'll have to use the long method. No? Sige, okay lang. Let's just use the long method. Pero, I think, wait lang ang class ah. See, I think we have one example here na if I can find it, no? Ay, magkaiba. Mas maganda sana to. Kasi may, ganito yung sinasabi ko na meron siyang data set mismo. Tapos, kumbaga, isosolve natin siya. Kasi since may data set na, automatic magko-compute siya ng ano, no, yung mga different values. Hindi ko alam ko. Kaya ba natin maloko si Excel? Can we generate a data set na sadyang 85 yung magiging average tapos a standard deviation is 4. Medyo mahirap na. So, let's just do the long method na lang. So, long method is since we have the H1 and HA na, H not and HA main, pwede na tayo mag alpha alpha na, no? That's the next step. Alpha is may binigay ba? Walang binigay, no? So, since walang binigay, again, if walang binigay na alpha value, just use 0.05. Meron pala. Ito, 0.05. So, we use 0.05. Tapos, given na yung averages and standard deviations. So, let's compute for first. Ang mahirap dito sa part na to is actually yung pooled standard deviation lang na calculation. No? But if you were given the data set, actually itong pooled standard deviation, automatic mako-compute na rin. So, let's compute for pooled standard deviation first, SP. So, to compute it, we'll just use the formula, no? Sabi dito is N1 minus 1. So, that's 12 minus 1. 11 times equals 11, 12 minus 1. Sige, 11 ko na lang diretso, class, no? 11 times the variance of the first data set, which is equal to 4 squared. Tapos plus N2 minus 1, which is 9, multiplied by the variance of the second data set, which is in this case 5 squared. So that's 5 squared. Then we divide this everything by the degrees of freedom, the total degrees of freedom, which is just N1 plus N2 minus 2. So that's 12. That's just 11 plus 9. No? Pwede nga 11 plus 9 or pwede ring 12 plus 10 minus 2. That should give you the same thing. Okay, so we have the pooled standard deviation of 20.01. Now that we have the pooled standard deviation, pwede natin makompute yung T-calc. No? So T-calc is equal to and by the way, if you were given, balik lang tayo dito, no? If we were given the data sets, dito mo ipapasok actually si D naught, itong hypothesized mean difference. Ito si D naught siya. And maybe I can show you one example that uses this D naught. No? That uses the data sets instead of instead of you already given the means and standard deviation. Sige. Try lang natin muna to, no? So we have T-calc, you have ano tayo? X bar minus x1 and x bar 1 is equal to 85. X bar 2, nakalimutan ko, equal sign. Equals, x bar 1 is 85 minus 81. Nakaharang. Ano nga ulit itong value na to? Is it 81? 81. So minus 81 minus the perceived difference, which is hypothesized mean difference, which is 2. Ang sabi, di ba, more than 2 units sabi natin. So minus 2 divided by the square root ng standard deviation 1 over sample 1, tapos standard deviation, variance 1 over the number of samples 1, tapos standard deviation variance number 2 over number of samples of dataset 2. So that's equal to 4 squared, and let me know if may mali akong input, no? Divided by N1, which is 12 plus square root, plus 5 squared divided by 10 naman. Okay? So we can do this class, no, kasi Excel also does MDAS, no. So siya na kumbaga multiply muna siya bago siya mag-add. So siya na bahala diyan. So T-calc is 1.021. Okay? Then let me Okay? So meron tayong T-calc. So we can compute for T-crit. T-crit is equal to same lang, no? Yung kincompute natin kanina, we should get T.INV. And this is a one-tailed test ulit. Tama? So, one-tailed test 0.05. And this is equal to, sorry. Since we are doing this on the right side, tama? Nasa right side kasi tayo. So, ang kailangan natin is yung negative nitong left-tailed test. Tama? So, we do T.INV of 0.05, tapos degrees of freedom natin is yung N1 plus N2 minus 2, which is equal to 12 plus 10 minus 2. Okay? So pwede ganyan. Another way of doing it is you can have this, or pwede rin naman gawin natin is equals 1 minus T.INV ng 0.95 naman. Okay? So pwedeng kumbaga to the right side tayo. But since its measurement is or since it does left to right, then kaya 1 minus T.INV yung gagawin natin. Plus 20, no? Kasi 12 minus plus 10 minus 2. And you should get, wait lang. 12 plus 10 minus 2. Tama naman. T.INV. Wait lang, klasa. May mali ba akong input? They should give me the same. Let me look at the T distribution. The T distribution is symmetrical. Ito yung symmetrical, no? So, bakit ang T.INV ng 0.95? Medyo I'm wrapping my head around this class, no, kung bakit siya automatic nag from the right side. Hindi naman siya .rt. Kasi dapat mini-measure niya from 0 to, unless kung greater than 5, mini-measure na niya automatic from the right tail. Not quite sure kung ganun niya ba tinitreat siya, no? So let's just, based on this behavior, no, mukhang if you inputted a probability that is to off the right tail, ang kinukuha niya is from from infinity to going to the left side. Okay? So let's just leave it at that, no? So pwedeng this is the safer one kasi mas madaling i-imagine. Kung walang negative, it makes sense na dapat negative siya kasi kumbaga nasa left side eh. So kaya natin i-negative kasi yung positive value yung kinukuha natin. So I'll have to look into this, no, kung bakit ano. Pero apparently ang behavior niya is if it's 0.95, then it measures it at the and just to try things, no. Kung 0.65, that's 0.39 equals siya sa 0.35. Tama. So parang if it's greater than, baka smart enough na si Excel. Now, if it's greater than 0.05, then it just takes the right-tailed na value. Tapos pagka left-tail, and just to be sure, pwede namang tingnan natin yung documentation. No? Let's look at the documentation remarks. If either argument, if probability is greater than 0, truncated. Left-tailed inverse of the student T distribution with a probability of 75. 2 degrees of freedom. Medyo, no, wala din sa documentation na nagsasabi. Sige. I'll try to look into this class, no. Pero right now, maybe it's just better to use eto, no, kasi mas intuitive, no. Na point ko since 0.05 siya, measured from the left, ganyan. Or we can also do yung trick natin kanina, no, that we did t.in.2t. Tapos instead of inputting a probability of 0.05, input tayo ng 0.1 naman na probability. So, you should get the same value pa rin. No? So, pwedeng ganyan. Okay? So, let's also compute p-value. P-value is computed as since we're looking for the area under the curve, ang gagamitin natin is t.dist, no? So, t.dist, and this is a one-tail test, and we are looking at the right tail, RT. Lagyan natin ng RT. So, we are looking at the right tail, and our T calculated is 1.025. 20. Pwedeng ganyan. 0.15. Or pwede rin actually, instead of looking at the right tail, pwede rin left tail as 1 minus ano na lang, no? Pwede rin from the left tail. Actually, it should give me the same. Tama ba? Since it's 1 minus. Tama. So if I do 1 minus t dot dist nito, oops, cumulative, it gives me the same value, no? So it gives me the same value because etong t dot dist is measured from the left tail, no? So parang from 0 to whatever value itong si B5, which is itong 1.0215. So since it's measuring from that, tapos gusto kong kunin yung from the right tail, then I just take 1 minus that value. So, which is, yun dapat yung expected behavior ko dito, class, no? But For some reason, hindi siya yung nangyayari. So, I have to look into this. Anyway, pwedeng ganyan. And pwede rin, lastly, pwede rin yung t.dist ng two-tailed. Pwede yung if full siya na two-tailed but instead of using 0.05, 0.1 yung gagamitin natin. It should give you the same value pa rin. 1.1. Wait, bakit? Sorry. Bakit 0.1 yung nilagay ko? Pwedeng ito, t-cap, tapos i-divide nyo na lang by 2 to. Kasi naka-two-tail to eh. So if you divide this by 2, this is a probability, this is an area, remember. Divided by 2, then you actually get the same value. So again, multiple ways to solve it. Kayo na bahala. Just pick your poison na kung ano yung gusto nyo. Okay? Now, let's end with the conclusions. And mukhang hindi tayo matatapos today, no? So what I'll do, class, no, is meron akong old recordings about this. So, I'll just give you the copy of the recordings para ma-explore nyo yung different, yung other, yung other cases naman so that you can do it on your own. Tapos, lagyan ko na lang ng timestamp siguro para pwede nyo i-skip, no? Tapos, hanapin nyo na lang yung other cases, yung specifically yung cases wherein we use, nakita niyo yung emails ko. Yung cases wherein we use, saan tayo tumigil? We ended with case, itong with different variances, no? And actually, if you look at the whole video, mas maganda yun kasi mas makikita nyo yung two other, yung usage ng different na values na to. Itong different formulas na to. It's medyo confusing siya, no? Kasi sobrang daming computation. Pero if you use the data analysis Toolpak, given the appropriate data set, no, kaya nyo actually further simplify ito. Case 6, 7, 8, 9. Again, itong case 1, 2, 3, just to summarize, no, itong cases 1 to 3 is for single means lang. So you are comparing your sample mean with a population mean or hypothesized population mean. Case 4, 5, 6 is when you are comparing two means. So dito, this is where sa first case is you have a known yung population variance and they are equal, yung two data sets. Dito, unknown yung population variance of the two data sets pero assumed equal. Dito, unknown sila and they are not assumed to be equal. Okay? Tapos case 7, this is what we call as a paired observation, no? So a paired observation, and usually class, ito yung na medyo nako-confuse yung mga students. Yung difference between comparison of two means versus a paired observation. So si paired observation is that yung each data set experiences two types of conditions, kumbaga. So for example, ang usual na dito, no, ang classic example of a paired observation is a before and after. So for example, before you take in the medicine, may kukunin na parang value sa'yo. Tapos after you take the medicine, may kukunin na value from you. So kumbaga, each individual sample experience niya both data sets. So if you look at, kunwari ito, deer 1, ito si deer 1, isang specific deer to na ininjectan at the time of injection, tapos tiningnan din after 30 minutes of injection. Kumbaga, if you look at deer 1, it experiences both. So kaya siya paired observation. Okay? Which is different from this one, no? Let's look at the data set that is not paired. Kunwari ito, unmodified, modified, and unmodified. You will be tempted to say na itong modified and unmodified is a paired observation, no? Kasi meron namang minodify mo muna tapos in-unmodify. Pero ang difference here is that kunwari itong sample 1 na to, not sa modified, does not necessarily have to be sample 1 na unmodified. Okay? So kumbaga pwedeng ang nangyari lang dito is you have 10 samples that are unmodified and 10 other samples that are modified. In that way, walang pairing na nangyayari. So nagigets niyo ba siya? So kumbaga walang 1:1 correspondence, no, na kung pag sinabing sample 1, modified siya and unmodified, same sample lang to. So pagka ganun, kung hindi sila paired, kung kumbaga walang 1-to-1 correspondence, then you use yung case 4, 5, 6, whichever is applicable. Pero kung paired siya, wherein meron talagang clear na before and after, meaning each sample experiences both conditions, then that is a paired observation. Okay? And that is one of the, siguro dito sa ano no sa MMME14, yan yung madalas nagkakamali yung mga students, no. They think it's a paired observation when in fact it's a ang tawag dito, a a comparison of two means, or baliktad, akala nila comparison of two means when in fact it's a paired observation. Okay? So dito okay lang ba kaya siguro kahit 5 minutes lang ipakita ko tong class, no, isang example wherein we use data analysis tool pa, kasi it's very helpful. I think you will appreciate it, parang mas magustuhan nyo kumpara sa parang no, yung long method of solving things. So let's just try to do this. Let's do this. Meron daw engineer that is studying the formulation of a cement mortar, tapos meron siyang modification na ginawa, nag-add siya ng polymer latex emulsion. Tapos, meron din siyang ginawang original formulation lang. So, may 10 samples na original, may 10 samples na modified. Tapos, tinignan niya kung meron bang effect yon doon sa product, no? So, based on these conclusions, let's test whether the mean tensile strengths are equal. So, meaning dito, hindi niya alam kung alin yung mas mataas. So, kung gusto ba niya, wala siyang ina-assert na directionality, kumbaga. Hindi niya ina-assert na the modified one is stronger than the unmodified. Gusto lang niya malaman if may difference ba yung dalawa. Okay? So, kung ganito, two-tail to. Okay? So, let's try to copy the data, no? And let's do this. Yan. Tapos, determine alpha, assuming both variances are equal. Sabi, both variances are equal, no? Since we are assuming both variances are equal, then this is also case 5, no? Or let's try to modify, no, the problem. Sabihin lang natin na we don't assume that the variances are equal, no? So let's say unequal sila. So kung unequal sila, what we do is, since unequal siya ngayon, case 6 yung gagamitin natin. So if it were case 6, dapat medyo mahaba yung formula na gagamitin natin, no? So if you look at case 6, case 6 has this formula, no? Magko-compute pa tayo ng sobrang napakahabang degrees of freedom. Tapos, ito yung pinakamahirap na part, yung pag-compute ng degrees of freedom. Pero, we can do that. We can skip that kasi si Excel actually can do this, all of this for us now. So, let's just do H0, H1. Tapos, we do the modified one, mu1. Mu1 is equal to mu2. So, that's our H0. Tapos, we can also do mu1 is not equal to mu2, which is what we are asserting here, no? Na hindi sila equal. May difference yung between the two of them. Pero hindi natin alam kung which one is greater. Okay? So, let me just show you na yung paggamit ng data analysis toolpak, no? So, if I use the data analysis toolpak, again, you need to activate it through file options, no? So, anyway, activated na sa akin. So, I go to the top ribbon. Hanapin ko si data. Tapos under data, doon sa pinaka-right, dito sa analyze na group, you see data analysis toolpak. Pag kinlik ko siya, may lalabas na ganito. So there are 3 cases, no, of the t-test. Pwede siyang paired observations, pwede rin siyang equal variances, or pwede ding unequal variances. So let's choose unequal variances, no. Tapos dito variable 1 range. So pipiliin natin ito. This is the variable 1 range. Then let's choose variable 2 range, which is dito sa variable 2 range. So hindi ko sinelect yung label, so i-uncheck ko lang siya, or pwede rin ang gawin natin is isama natin yung labels. Parang ganyan, sama yung labels. Tapos i-check dapat i-check natin tong with labels. Okay? Tapos ang hypothesized mean difference, wala namang hin-hypothesize na mean difference dito, no? Kasi kumbaga ang ano natin, hypothesis is just they are equal or they are not equal. Okay? So if that's the case, then dapat 0 lang to. This is the same as saying na mu1 minus mu2 is equal to 0. Or mu1 minus mu2 is not equal to 0. Okay? So 0 lang ilagay natin dyan. Tapos we can select our output range, no? And I just like to put my output range, kunwari, let's just put it in an open area, no? Kunwari dyan. Output range dyan. Now if I click OK, automatic ibibigay niya sa akin yung data na to. So meron na siyang T-statistic. T-stat here is the T-critical. Meron din siyang p-value for the one tail. May p-value din siya for the two tail. Meron siyang T-critical and meron din siyang T-critical for two tail. Sorry. T-stat is the T-calculated. I mean. So T-calculated, may T-critical siya, and meron din siyang p-value. So it becomes very easy, no? So if we do this, also, if you don't like to use the data analysis toolpak, meron din built-in na t-test dito, no? So if you do t.test and you select array 1, which is this one, array 2 is this one, tapos you pick the number of tails. Again, dito we don't have any directionality to it, so we do a two-tail test, 2. Tapos dito, yung type is, type 1 is paired, type 2 is equal variances, type 3 is unequal variances. So we have type 3 to, no? And if we input that, we get ang nakukuha natin dito is actually a p-value, no? This is a p-value. Okay? So, if you look at this, itong p-value na nakuha natin is 0.043, which is equal to actually this one, no? Itong two-tailed na p-value. So kumbaga mas complete lang tong si data analysis toolpak, so you can use that if you want. Pero ito mas concise siya, no? Parang you get exactly what you are looking for. Itong si t.test. Okay? So let's complete this. Alpha, our established alpha is 0.05. Tapos we got our t value, our t-crit, t-calc muna. T-calc natin is this value. So I can just do equals this one. Tapos ang t-crit ko, this is a two-tailed test. Therefore, I'll do t-critical this one right here. Okay? So, gagawin natin is since conclusion time, since if you do hypothesis testing approach, you do since the absolute value of t-calc is greater than the absolute value of t-crit, then reject h0. Okay? Tapos, pwede rin, since p-value is less than alpha, then reject h0 as well. And then you can conclude that the two data sets are not equal. Pwede ganyan. Or pwedeng mas accurate mo. Pwede yung isabihin. Pwede actually ito. The mean tensile strength of the two data sets are not equal. Pwede ganyan. Okay? So that's one way you can solve this, no? And actually itong t-crit, may ways din to solve this, no? Pwedeng kunin nyo lang dyan or pwede din mag-solve kayo ng sarili yung t-crit, no? So you can do t.inv ng probability natin. We have a two-tailed test, no? So 2t. Probability is 0.05. Degrees of freedom natin is, mahirap i-compute yung degrees of freedom. So kunin ko na lang dito. So, ganyan. So, I got 2.109, which is the same as yung nakuha ko dito, no? Okay? So, nasa inyo na. I suggest itong data analysis toolpak na lang, no? kasi mas madali siya. Pero if you don't have Excel, so kunwari meron lang kayong um, kumbaga ang available lang sa inyo is Google Sheets or some free version of Excel like LibreOffice, then you can still compute for T-calc using ano no, T.test. Itong p-value na to, you can still use T.test. Okay? Tapos masosolve nyo pa rin naman siya. Okay, so yan lang muna. We will end there. And I'll just link a video to the other cases now where we solve for different values of the other cases. Okay, so thank you for coming in today, class, and I'll see you next week.
Thank you din po, sir.
Okay. Sana masarap ulam nyo.